Friends, wouldn't it be great if we could ask questions to ChatGPT about our personal data? As of now, we know that we can ask questions about any publicly available data, or if we are a developer, we ask questions about coding or programs, and it helps us. But wouldn't it be great if ChatGPT could answer the questions related to our personal data? But of course, ChatGPT is not trained to do so. ChatGPT or any other AI model is not trained on our personal data. But in this video, actually, I'm going to show you a design in which we can ask questions on our personal data, how we can train AI model, or I would not say train specifically, but to use AI model to ask to generate answers based on the data that is personal to us or custom to us. So let's get started. So this is the design that I am going to use, so that I can use AI model to answer the questions based on my personal data. So this is a high level design that you can see on my screen, and I'm just going to explain all the components of it, and then I will write the script and show you on my terminal like how it actually works in the background. So starting from the top, these symbols represent the text file inputs and Excel files. So suppose my personal data is in the text files and it is unstructured data, and I will take an example of a daily diary. For example, someone is writing a daily diary, and he's just putting up whatever thoughts come in the mind about the people, places, and lots of stuff, and it's all scattered and unstructured data. Another form is Excel file, where the data is structured. There are defined columns, and the data is based on these columns regarding some persons, their address in the city, and what they like. So I'm going to use these two examples as text files as an example of personal data. Then the idea is that I will feed these personal data to generate embeddings. So the embeddings are basically a way to represent our data mathematically. In a nutshell, it is a representation of our data in the numerical form or in the mathematical form, so that it can further be processed by the vector DB. So next component in our design is the vector database. So vector database is something we are going to use to store these embeddings. So the first step is to just generate these embeddings, that is the mathematical representation of our data, and next step is to store it in the vector database. And now it would come across, the question would come across your mind that why we need this vector database, and why we need to store data first into vector database and then use AI model. This is because actually it's very much costly, or not feasible to directly use any available model directly on your data. So for example, in this model, what I'm going to do is I'll store the data in vector DB in the form of embeddings, and then my application will query this database, vector database, to get the context of my questions. So there is an end user, and this end user is asking questions about the data, about the data that is present in the daily diary. So daily diary that this person has written over a period of time, unstructured data. The end user is asking question. This application actually queries this data, the related data related to this question, into the vector DB, and based on the data that is stored in the vector, it gives the context about the question. So it provides some information about the question, some context actually, and then this context information is sent to the AWS Bedrock AI model. So for this particular example or use case, I will use the AI model that is provided as a service in the AWS Bedrock, and this AWS Bedrock service will actually use the response from vector DB, and it is going to provide me the accurate answer. So it will become more and more clear when I will demo it in the background, but just understand this diagram from a high level, is just to understand the steps involved in this process, and why this particular design I chose is it's important to note why we choose this design, because later when you will see that if end user has any question about the data, so why we are doing this process, that we are putting this into the file, into the DB, and why not we send this whole file directly to our model, and then our model maybe should be able to read these text files, Excel files, and automatically extract data and just answer the question. The most important reason why it's not possible, it's possible maybe if you have just 1 kilobytes of file, 1 KB of file, but it's not feasible even if you have some 100 MB of data, right? So it's not possible because of this cost involved. So this if I ask AI model to process any text file of 100 MB, it can definitely do it, but then the cost will be very high, because the way AI model works is based on tokens, and token is something that's a kind of bandwidth or the limitation how much we can use this model, and there is always a cost associated with the use of the AI model. So I will just go through these steps quickly, and then I will move to the background. So first is that I will generate text embeddings. So I have one script. This whole demo is based on two scripts that I have written in Python, and this one script is just basically ingesting data from these text files, and it will generate the text embeddings. And when the text embeddings are generated, I will insert these embeddings into the vector database. End user asks a question, end user will then prompt a question, and chat app queries that data from vector database based on the question. The chat app will basically send query this database based on the keywords that are present in the question. Chat app sends vector database response to AWS Bedrock as a context. So suppose I have 100 megabytes of file which is full of data. It's in the vector DB now in the form of embeddings. Now end user asks a simple question, and then based on the keywords, the vector DB will provide few lines of answer with a score. It will provide some context to this question, and then this context will actually be sent to the AWS Bedrock, and AWS Bedrock will use the AI model and will analyze the context data that I get from vector DB response, and then respond back with the accurate answer, and then this accurate answer is visible to the end user. So let me go to the terminal to just show you how this setup looks. So there will be basically two scripts that I will be using. One is just to embed the data, ingest the data into the DB, and another script is basically to query the data from DB and communicate with the AWS Bedrock. Let me go to the terminal window. So in my terminal window, I have already set up the environment. So in this example, I will be using FAISS. This is actually an open source vector DB, and this allows me to store the vector embeddings, and this is open source from Meta, and it's very useful for doing this local POC. But it's important to note that there are other vector DBs available to use, which are highly scalable also, and can be used with a huge amount of data set. So let me show you how the setup looks. So in this directory there are few scripts that I run in Python to install the packages that are required to ingest data, that is basically to generate the embeddings out of my text file. So in the data directory I have my data, my raw data. Index is basically the index folder is basically used by this vector DB to generate the index based on the index embeddings that I feed to this via my script. And source is basically where I have kept my scripts. So let me show you what's in the data folder. So in data I have further created placeholder for Excel files, PDF files, and transcripts. So I will quickly go to the transcripts and show you how the data looks. So you can see two data files. Let me just show you data 1. So as you can see on my screen, it's just a very simple text that is present in my file. That is, Mayank started his career in 2010. There is another person, Jatin, he was promoted to engineer 2. Kanika was not happy with the promotion, Jatin, so she booked a trip to London. I mean, it's just a very random data that I just typed, and you can see that it's just a simple and structured data. Now I will just show you what's in the second file. So mm, so second file also has let me just, impossible to maximize. So yeah, I have increased the size of the Mac terminal, and as you can see the data from two files. This is from file 1, there is some random data, and this is from file 2. This is another set of random data, like this person returned from London 2018. Mank and Jatin found about their success, and then they eventually got rich. I mean, I will share all this data over a GitHub repo, and you can just download them on, and you can also create your own data and play around it. So so these are just two data files. Let me go back and show you what's in the other directory. So this was in the transcripts. Let me go to the Excel, and there is also an Excel file. To show the contents of Excel file, let me come over here. So this is just a simple file where I am just I have just name, address, occupation, likes and hobbies, and distance from city center for some people. So this Excel sheet is stored at this location in the Excels. PDF is empty as of now. I am not going to show any. I'm not going to generate any embeddings from PDFs. Let's go back. Okay, let me go to the source folder now. So in the source folder, you could see that there are some queries. Let me remove this query that I am not going to use for this example. And yeah, so this is the ingest query that I am going to use, and ingest query is basically going to read the text files, and it's going to just generate this embeddings and put it into the vector DB. and then I will run this query script, and this query script is basically going to show you how I can actually query this database and how it generates the context of the data based on my question. So let me just first run this. Then ingest. So don't worry about this script. I will share the script completely in the in the description of this video. Okay, it has run. So it has ingested, and now I am simply going to query this data. I am going to run this query script. Okay, so I can ask any question about data. Let me go to the data to see. Suppose there is a data that says Kanika is very good at playing chess. So let me ask this: is Kanika good at playing chess? So this is the response from this vector DB, and this is how it responds. It generate the response method in terms of score, and it has produced this 5 metadata context based on the data in the vector DB, and the score 0. 0.6 is the highest score. It is sorted on the base on the order of score, and the score 0.6 is higher than 3, and it represents that this data has something some answer about our question, and it can be further used to answer the exact question. For example, at the end you can see Kanika is very good at playing chess. So it has already got this text, and now it has also found some other data like when they returned and all the other stuff which is not exactly able to answer the question, but you can see that it is picking up like chess. So this Amit address, it is from Excel file. You can see the source, and it has picked up this data in the query as a query result, because it has this keyword chess. So let me ask something else. uh, Happy with the promotion. Okay, let me ask why Kanuka was not happy. Yeah, so again it has produced this score, and also it has also provided that Jatin was promoted and Kanika was not happy with the promotion. Let me ask another question that which data is in the Excel. For example, I can simply ask what is the address of maybe Devi. Okay, what is the address of Devi? So at present, at this stage, I haven't started using the AI model to answer these questions. These questions I am asking, and the response I am getting from the vector DB in the form of scores, and these scores are basically the metadata, and it provides me the data that is related to my question. For example, it has picked up on the first, it has picked up with score 0. 0.6, and it says that the address of the Devi could be this. Now I'm going to actually use my second script, that is the answer bedrock. So this query is basically was there just to demo like how we can query the data from the vector db. But the actual work I am doing is in the answer bedrock, where this query is first, my question is first, I am querying the data in the vector db, and then I am sending all of these context directly to the Amazon Bedrock, for so that AI model could further analyze this data and give me the accurate result. So let me just quickly run this script and show you how it is able to communicate with the Bedrock. Mm, yeah, Python. Bedrock, and my question is same. What is the address of Delhi? It is surprisingly taking more time than expected, maybe due to slow network. Let's wait for a few seconds. Is the address of Delhi? Okay. So first it tells me like how much score it has retrieved from the vector db, and then it gives me the answer. The address of devi is this, C87 second floor Sarai Delhi. Let me verify this, C87 Sarai for Delhi. So you see how this is, how amazing it is that I can directly query anything from my personal data. Let me ask just one more question based on the personal data. Just a second, let me scroll back again. So success. So Mike and Jatin could not get rich in USA, but both of them went to China. This is from second file. Yeah, okay. Let me ask this question. Let Oh, it has now provided me the answer that I don't know from the provided context. So, if it is not able to find something that is present in your data, then it tells you that it's unable to provide you based on the context. Let me ask one more question. Did ever get rich? Oh, it says that yes, Mayank eventually got rich. States that Mayank and Jatin could not get rich in USA, but later they went to China, where they set up a business and got rich. But okay, so you can see like maybe it has little bit of glitches that can be very much easily adjusted by manipulating the script, but that's definitely working out very good and giving very good results on small data sets. I have asked many questions earlier based on this data set, and now I will give you a little glimpse of this bedrock file. and how it communicates with AWS. So you see this query that chat terminal is basically communicating with AWS Bedrock model, and I have created another video just recently, just previous to this, that actually shows this setup, where I have provided in-depth analysis how I can set up script that can communicate with the AWS, what model I can choose, and how to set up the permissions. So I'm just following that process. You just watch that video, you will be able to complete this much process by watching that. Let me also show you how the script looks. Just a second. So this script is basically uh, making connection. Let me show you the model. Basically, I want to show you this model. Okay, here is the model details that I'm using. I'm using Amazon Nova Lite model to answer these questions, but you can easily use other models in this script. By watching this video, you will get to know how you can select the models, and with more different models, you can see that which are more suited to which type, processing which type of data. So I think that was all for this video. Let me know if you have any questions, and in the refer the description, where I will share all the scripts and step-wise details as how you can set this up on your local. Okay, thanks. Bye bye.